So good morning. My name is Dr. Chinna. Goud. So I am the assistant professor in the EEE department. So today we are going to discuss about the DC machines and its construction. So the cutout section of the DC machines and what are the components available and what is the material used, what is the purpose of each and every component. So in the syllabus we have DC machine types and construction details. Today we are going to see the construction details. So in the construction details, mainly in the laboratory also we have a cutout section, and the syllabus also we have a cutout section of the DC machines. So DC machines, either we know that machines will work on the electromagnetic conversion. So machines according to their work, they will divide it into the DC machines two types, that is DC generator and DC motor. So as we know, DC generators means which converts the mechanical energy into electrical energy, and motors means which will utilize the electrical energy and convert into mechanical energy. So here in the DC machines, either motor or generators, the construction is almost same. So there will be a small parts. So remaining everything construction is, main construction is same. So we will discuss that it is a DC machine construction. So we will see main constructional features. So here we are showing the cutout section of the DC machine. So in this DC machine, they given the small components. So commutator, armature winding, armature, air gap, shaft, stator winding, stator, carbon brushes, frame and cooling fan. So these cutout sections, we are going to check that what are the components available. So mainly we are going to check 10 components. In that one, first one is body, magnetic frame or yoke, and then pole core and pole shoe. Then we will see the field and exciting coils, and armature core, armature winding. Then we will see the commutator, which is the most important part in the DC machine, and then brushes, and then end housings, and we will go with the bearings and shaft. So whatever the components available, we are going to check one by one component, what is the purpose of these components and how it is made up of. Okay, this is the cutout section which is available in our laboratory also. But in the exam, during the exam, we have to draw the circuit diagram. So we will draw the circuit diagram in this way. So each one will represent. So once we will discuss about each component, we will come back to this diagram and we will see what are these components. So the first part is body and magnetic frame. So the magnetic frame and yoke. We know that it is a frame. What is the purpose of frame? So generally the frame will protect the whatever available, like photo frame we will take. In the photo frame, the frame will protect the photo. So here the frame will protect the complete machine. So inside machines, it will provides the mechanical protection. It will provide the mechanical protection for the inner parts of the machine. So either it is a generator or motor. And second thing, it provides the low reluctance path for the magnetic flux. As we already discussed that in a DC machines, how EMF will generate by using the Faraday's law. So the conductors has to cut the magnetic flux. So that flux has to move, flux has to generate. So for that flux, it will generate the low reluctance path in a DC machines. So we'll come back to this point when we will discuss about the pole. So what is the material used? So we have to remember that generally whenever we'll say if flux is involved with that one, so those are the magnetic materials. So there mostly we will use the iron and steel. So here we are using the cast iron, silicon steel, rolled steel and cast steel. So either steel or iron we will use. For the small machines, generally we will use the cast iron for small machines because their weight is not a important criteria, important concept. So we will take, for small machines we will use the cast iron. For small machines we will use the cast iron. But where it will come to the big machines. So big machines, it is not possible that the cast iron is the more weight when compared to the steel. So we'll go with the silicon steel. And as well as for the small machines, single roll is not possible. So what they will do, they will make as a construction. Suppose this is generally we will use for the cast iron. So what they will do for coming to the big machines, they will use as a laminations. They will use as a laminations. So like this they will make as a laminations and they will fix it. So this is for the big machines, they will use these laminations and they will use for the steel. So this is about the frame and yoke. Coming to the second part. that is the pole core and pole shoe. So pole here we have to generate the magnetic poles. As I told before, we want the magnetic field system. So we have to create that magnetic field system. So that flux, so we want a magnetic pole core and pole shoe. So the core, which is it has to distribute the magnetic flux. So this shoe will be useful for that one. So the main purpose is it will support the field windings or field coils. So the coils has to be houses on this one and to generate the magnetic flux, and then it will distribute the magnetic flux in the armature periphery more uniformly. In the armature periphery more uniformly. So what is the meaning of this one? We will see. So the pole core and pole shoes are fixed to the yoke by bolts, by bolts. So what is the meaning of it? We will see. So what is the material used? As I said, this is also dealing with the magnetic flux. Whenever flux will come, there will be steel will come. So this is also will be made up of cast steel and cast iron. Here if you observe in this diagram, so this upper part, whatever this upper part is there, this is pole core. So the main where we will keep the windings and everything. So this part is there, which is a curved shape. So this is a pole shoe. This is a pole shoe. So the pole core purpose is, suppose the field winding, this pole shoe will distribute the magnetic flux properly. So up to here whatever we seen, this is the magnetic pole core and pole shoe. So why we laminated this? If you see, these are the pieces, that pieces are laminated. So what generally they will do, so instead of using the single one, they will use the piece-wise lamination sheets, and they will do with hydraulic pressure. With high hydraulic pressure, they will fix it. Why we will do this one? Suppose we want to increase the strength of the machine. So what they will do, they will bring another sheets and they will add again and they will make it. And this is the generally the pole shoes have large cross-sectional area. As we know that flux density B is equal to phi by A. So flux is equal to B into A. So large cross-sectional area, the reluctance for the magnetic path will be reduced and it will go through it. Okay. So then, and this is the laminations and everything as we seen. So as I told, so how this pole shoe and pole core are fixed to the yoke. So if you see here, so these are the bolts. So they will fix it to the bolts to the yoke. And now, so these are made up of laminated steel assembled together with the hydraulic pressure. So the next component is field coils. Because we have a pole, we have a pole core, and that pole core somebody has to excite. That's why these coils are also known as exciting coils. These are also known as exciting coils. So these are used to magnetize the pole core. So the pole core is the electromagnet. So magnetize the pole core, we will use the exciting coils. So how we will use these exciting coils means we will take similar type of the pole core wooden block and we will fix the winding to that wooden block. That complete winding setup will bring and will keep it on pole core. So as here you can see, so this is completely we made up of field coils separately. We just winded all the coils and just will bring and we keep on the laminated pole core and pole shoe. Just will fix it. So what is the material used is enameled copper. I told you we have two things, electromagnetic conversion. So electrical elements means mostly they are made up of copper and aluminum, and some are carbon. So carbon, aluminum, copper. So here these are we are using the copper vials. Enameled copper means coated copper. So which will be coated by the elements. So that is enameled copper. So whenever the direct current, so because we are dealing with the DC machines, direct current we will send through the coils. So these coils will set up the magnetic field and magnetize the pole core for the required flux. So up to here we seen the whatever the magnetic flux is going. We'll go back to our diagram. As I said, we'll come back to this diagram. So here you see, up to now we seen the yoke. What is the purpose of it? It will be mechanical support to all the machines inside. And second thing, it will provide the flux. And we'll come to the field winding. So if you observe, this is the terminal blocks. So whatever I am drawing, so this one is the field winding it is going. Suppose I will consider the current is going from here. So this is the positive winding. So we are giving positive current. So current is going in this direction. Again, it will come back. So it will go in this direction. And again, it is coming. So it is going upper way. And again, it is coming back. So it is coming. This is the direction of the current. So again, it will go. It will come back. And again, it is reaching to negative terminal. So this is complete field winding. Whatever just now I noted, that is completely field winding. So the field winding generally will represent with F FF. Field winding will represent with FF. So in this field winding also two types are there, shunt type and we also have series type. So here we are going with the basic construction only, so I am not going in depth. So we are taking the field winding into F and FF, F and FF. Here, so like you see, so how this is fielding. So we have two types of poles, north pole and south pole. So generally we know that if suppose this is a permanent magnet, this is a north pole and this is south pole, the flux will flow from the north pole to south pole. So this is the direction of flux. So the flux lines will be coming outside from the north pole and it is going inside towards the south pole. So here we are generating the electromagnet. So electromagnet, generally what will happen if you have a electromagnetic material, so we'll keep the winding. So we will keep the winding. So this is the direction of current. So if you want to know which is the north pole, which is south pole, generally we will use the right hand thumb rule. So what is right hand thumb rule is saying, suppose you have a conductor. So in the conductor, so the current is flowing. Suppose this is a conductor, AB conductor. So current is flowing from A to B. So then he is saying that you have to keep your finger towards the A to B and remaining fingers will show the direction of flux. Suppose current is towards me. So I am keeping thumb towards me. So this is the current, the flux direction. So this is the clockwise for you. So this is the clockwise. So suppose current is towards you. So I will keep thumb towards you. So the remaining fingers will show the anti-clockwise. So here also, if suppose I am taking this one. So whatever this example, if I am considering. So here if you see, I am using my right hand thumb rule. So current direction is upward. So because we are sending whatever I told. So if current direction is thumb, flux direction is remaining fingers, it is vice versa. Suppose if you keep your fingers in the current direction, thumb will show the flux direction. So here if you see, I will keep my fingers in this one. So my thumb direction is from my right side to left side. So this is the direction of flux. That means flux is coming from here outside and flux is entering this side. So then it will become the south pole, then it will become the north pole. So in the machine also we will design which is north pole, which is south pole by using the right hand thumb rule. So here if you observe the first part, this part, if this pole if you observe, current is from my right to left, so flux is downside, so it is giving the flux. So this is north pole, it is giving the flux. So here if you observe this one, so this is, it is upward, from down to upward, so flux is taking, so this is south pole. And if you observe this one, if you keep from left to right, so it is giving, so it is north pole. If you take this one downside, so it is south pole. So here if you observe, this is the pole core which is housing the winding, and downside this is pole shoe. Whatever the north, this is flux is giving, whatever the flux is coming from outside from this one, uniformly it is distributing the flux towards the periphery of the machine. So this armature periphery. So that is the purpose we told. What is the purpose? So it will house the field winding and it will distribute the flux uniformly. So that is the two purpose of this pole core and pole shoe, and field winding which is generating the magnetic field as I said. And next one is yoke. So we know that in magnetic flux also, if you see inside it is going from south to north, outside it is coming from north to south. So here also what will happen, flux will come from here. So this is going to south. So two lines will go here. Sorry, this is actually we drawn in reverse. So south pole will take the flux. Takes the flux. So whatever the flux is coming, again it will go to through this yoke. So that's why we told yoke have two purposes. One is the mechanical strength or mechanical support to the machine, and second one is it provide the low reluctance path to the magnetic flux. That is the meaning of this one. So with this one, so we completed the magnetic circuit part of the machine. Now we want conductors. Then we will go to the next component, that is field winding is over. So we understand what is the field winding and its purpose. Next, armature core. This is the main part of the conductors, electrical part of the conductors. but this core is divided into, armature is divided into armature core and armature windings. So core mainly what it will do, this is the rotating part. Up to now whatever we seen, those are the stationary parts. So in generally machines commonly will use the word stator and rotor. So the parts which are in a static position, that means not moving, those are known as stator combinedly, not a single term stator. Similarly, so which is rotating, all combination of rotating parts is known as rotor. All combination of rotating parts are known as rotor. So this armature is a rotating part of the DC machine. So in that one, first one is armature core. So as I said before, pole core means which will the core of the pole creating. So here also for armature windings, the main core is armature core. So what is the purpose of it? So armature windings are there, that means conductors are there. So it will houses the conductors. So it will give the slots. So it contains some slots. So we will see in the diagram. So this is the armature core, complete core. So if you take one lamination, so it has the slots. This is the slot. So these slots will provide the house for the armature conductors. Provide the house for the armature conductors. So it provides the flux, whatever the flux is coming from the field, so it will provide the path to that magnetic flux. That is the main purpose of this one. But here if you observe, if it is continuously rotating, it will change from north pole to south pole to north pole. So because of this continuously reversing flux will be available. This reversing flux will cause some losses. Those are the hysteresis losses. This is magnetic property of the steel. So what we will do to reduce that one, we will impure the steel with the silicon. So to reduce the hysteresis losses, we will add the silicon to the steel. So silicon steels we will use. And second thing, as I said, Faraday's law, if conductor cuts the flux, it will generate the EMF. So here also same thing happen. Some eddy current EMF will induce in this core. That EMF will induce the current will induce the losses. So these are known as eddy current losses. We have to avoid these losses also. So what we will do, we will use the laminations. We won't make one bulk steel. So we'll make laminations of steel, very thick and thin sheets we will take, and with mica we will insulate that one, and then we will make it as a laminated. So that is here laminations. If you see, it is not only one sheet, this is the laminations of sheets. So that only here we mentioned as eddy current losses to reduce, we will use the laminations. For reducing the eddy current losses, we will use the laminations, and for minimize the hysteresis losses, we will use the silicon steel. So as I mentioned, material used is low reluctance cast iron material with the laminated steel. Okay. So this is the armature core. Then coming to the armature winding. So as I said previously, in the slots we will keep the armature winding. So the armature winding is the main heart of the machine. So if it is a generator, the armature conductors only will generate the EMF, and if it is a motor, it will take the EMF and convert it into the torque. So here, what is the purpose of this armature windings means? So these windings will connect. So here they are mentioned that these all conductors we won't keep one by one, they will keep in a form of coils. They will keep in a form of coil. So coil means generally we will take minimum 2 conductors is single turn coil. If it is more than 2, we will take the 2-3 coils we will take. So here the purpose is in a generator. The generator, what it will do, mechanical power is converted into electrical power. In a motor, what it will do, electrical power to mechanical power. That is the main purpose of these windings. And material used as usual, it is carrying the current. So definitely it is made up of copper. So enameled copper we will use. So as I said about the conductors, if this is one conductor, this is another conductor. So these two conductors are connected. This is known as single turn coil. You can ask what is the purpose of it. So when we are keeping in a round manner, this back connection won't be available for the magnetic field. This back connection won't be available for the magnetic field. So this is back end connection we will call. This is back end connection we will call. And the front end connection, whatever it is there. So in the front end connection, whatever it is there, so that is known as front end connection. This is known as front end connection. So this is known as back end connection. This is known as back end connection. So here in this winding also, according to the connection of these coils, it is 2 types. According to the connection of coils, this is 2 types. According to the connection of coils, this is 2 types. So depending upon the types of interconnection, these coils of the winding can be classified into 2 types. That is, one is the lap winding, another one is the wave winding. So lap winding, as it is mentioned, so these conductors are connected in a parallel paths, because all the conductors we are not able to connect in the series, so we will connect in a parallel paths. How many poles are available? That much of parallel paths. So this is the connection diagram. So if you see here, 4 poles are there, so these windings are connected in 4 parallel paths. So here main important thing is we have to remember, so parallel paths will be A. So we will compare parallel paths, we will represent parallel paths with A. So this is equal to number of poles. P is the number of poles. So all the conductors will connect in a number of parallel paths. Here they will connect in 4 parallel paths. So definitely the conductors will divide number of conductors by poles. So the mentioned here, suppose there is a P number of poles and Z number of conductors, then there will be P number of parallel paths will be available. So this P number of parallel paths will be, the conductors will be Z by P number of conductors in series. So here we have to remember this one, so then only we will understand that how much EMF is generating. As we know that in series connection EMF will add, parallel connection it will be same, and in series connection current will be same, and parallel connections current will be added. So that's why we have to remember how many parallel paths are available. So the number of brushes also will be equal to number of parallel paths. How many brushes will be there, that much of parallel paths will be there. If clearly if you see in this one, number of parallel paths is equal to number of brushes. So number of brushes is equal to number of poles. Why means parallel paths is equal to poles and parallel paths is equal to brushes. So indirectly brushes is equal to number of poles. But here we have to observe, generally we will get the positive and negative. So that's why they told that half of the brushes will be positive and remaining brushes will be negative. But whereas coming to the wave winding, it is a very simple winding. There will be only 2 parallel paths. So positive, so there will be 2 parallel paths. So like wave progression it will go. So the parallel paths will be always 2. So that only they mentioned, if Z number of conductors are there, only 2 parallel paths will be there. How many parallel paths? That much of brushes. So definitely only 2 brushes, and conductors will be divided into Z by 2. If suppose we have 300 conductors, 150 in series in one parallel path, 150 in series in another parallel path. So this is about the wind. Now we know that conductors are available. So magnetic field is available. So these conductors start rotating. It will induce the EMF. But that EMF somebody has to send outside because it is rotating. It is evaluating. And one more thing, in the generated EMF is alternating EMF. It is generating alternating current. But we want direct current because it is a DC machine. It has to convert mechanical energy into DC electrical energy. And we will give the DC energy. It has to produce the torque either in clockwise or anti-clockwise. So this commutator is the main part of the DC machine which will convert the alternating into the DC outside. So this rotating parts, whatever is the rotating is there, it will connect with the stationary. Outside is a stationary, inside is a rotational. So the combination in between this commutator will work. So what is the purpose of this one is, it is the connect the rotating armature conductors to the outside the stationary parts with the brushes, and it converts, see, alternating current induced in the armature conductors into unidirectional current in generator action. So in generator it will do that. In motor, so alternating torque into unidirectional torque. So it is the purpose of the commutator in DC machine. So here in the diagram also we will see whatever the AC is generating, that commutator is converting into DC. I know it's not pure DC, but it is only for the single turn coil we will take, and if you take multi-turn coils, then automatically we will get the DC. That we will see in the principle of operation. And here you can see these are the commutator segments. So these commutator segments connected to the brushes. These commutator segments is connected to the brushes, and you see these commutator segments are insulated with mica. We will see in depth about commutator here. So this is the commutator segment of DC machine. If you see, these are copper brushes because anyhow it is carrying the current, so definitely it is made up of copper. So these are the copper segments, and these copper segments are insulated by the mica. And you will see this is the riser. So we have to connect all the field coils, whatever front end connection we discussed, that one it is connected to these risers. So same thing we mentioned, commutator is the cylindrical shape and made up of the copper segments, and segments are insulated by the thin sheet of mica. So these all the segments are connected with the means of 2 V-shaped rings, and V grows into the segments. So that is the in depth they are saying that V segments will be available, and each armature coil is connected to the commutator through the segment riser. So this riser will allow to connect all the coils. So this is made up of copper segments and insulated by the segments with mica. So here we will come to the brushes. So we are discussing here, we will come to the brushes. What is the purpose of these brushes? So we already seen whatever the alternating current is coming from the commutator, that it will taken by the brushes and it will give to the external circuit. That is the first one. So it will collect the current from the commutator and apply the external load to the generator, and similarly in the motor it will collect from the outside and it will give to the machine. So that is the commutator to collect the current from the external source and apply to the commutator. It is in the generator, it is in the motor. Actually it is not written here, so it is in the motor. And what it is made up of? So we don't want the friction. It has to be very smooth with the commutator and it has to be a very good conductor. So definitely we'll go with the carbon. So this is the carbon brushes. So brushes are made with high grade carbon and they are in the rectangular shape. So why they are in the rectangular shape means these things we can keep in the brushes, I mean holders, brush holders. So that we can keep in the brush holders and we can easily will convert the from commutator to the brushes. And the position they are telling, the connecting link between the armature winding and the external circuit, and brushes are held in a particular position around the commutator brush holders. Here will come end housings and bearings, the last parts of the thing. Now machine is ready, everything is ready. So we will use the end housings to close the machine, because our yoke is in a cylindrical shape and everything we kept armature in the inside. So we have to keep the side. So end housings will be available, front side one end housing, rear side means back side. So rear end housing. So front side housing means there will be a commutator, brushes. So it will support the commutator, brushes and also the bearings. So here bearings I mentioned here. So bearings to reduce the friction, because moving parts are available. It has to move very smooth without a friction. So we'll use the bearings. So that is the purpose of bearings, the friction between the rotating and the stationary parts. So they fitted to the housings. So these housings they will fit. So front side it will deal with the brushes and bearings. Back side there is no brushes. So definitely it will deal with the only bearings only. That is the purpose of end housings, and this is the purpose of bearings, and these are generally made up of high carbon steel. The final one, the great one, is the shaft. Why means somebody has, these all are rotating, somebody has to give the support to them. So all the rotating parts are connected to this shaft. The shaft has maximum braking strength. It should not brake with that much of speed when it is rotating. So all the rotating parts will connect to this one, like armature core, commutators, bearings and everything. And this will be made up of mild steel. Made up of mild steel. Mild steel means the steel they will keep at a particular temperature and they will cold at some places. So through some process they will prepare this steel. So with this one we seen all the components, which are the main components. So here we can see clearly, we can observe that like we discussed whatever we discussed from starting onwards. So this is our yoke. So this yoke, everything is available. You can see this is the bolt to fix the poles. So whatever the pole is prepared, we have the winding. So we have the winding. So winding is fixed to the pole core and shoe, that is fixed with the bolts to this one. So because of that one we will prepare the yoke and magnetic field. And then here will come, this is our armature, this is our shaft. This shaft we connected the armature. So these are the armature conductors. Whatever the armature conductors came outside, those are connected to the commutator. So the commutator is connected with the brushes. So this is the brush holder and brush will keep on that one, that is the connector. So this is the brush arm. So this one completely will keep on the housing. This is the end housing. So this end housing will keep and everything will fix it to inside. So this is the complete DC machine construction. So and as we said, if you will come just to discuss here, so what will happen in the DC machine. So while in the exam you have to draw the circuit diagram and explain each and every term, what is the purpose of it, what is made up of. Here one more time I came here to this diagram. So this is the armature core, these are the armature slots, and in between armature conductors are available. So these conductors, whatever the wire will come, that will come to the brushes. Here 4 poles are there and 4 brushes will be available. So 4 brushes means this is which winding? Definitely it is a lap winding. So lap winding 4 brushes are there. 2 brushes is considered for the positive, 2 brushes considered for the negative. So this is positive, so this is negative, this is positive, this is negative. So these two are connected, positive and positive are connected, and negative are connected. That will become the armature winding outside. So this is the armature winding represented with A and A. So with this one completely we see in the construction of the DC machine. Okay, so I hope you understand what is the construction. So we have to go through with the each and every purpose. Here simply if you observe also, all the things which are connecting with the material, flux, the material is steel or iron. If they are involved with the current, the material is copper and carbon. So that much easily we can remember that what is the made up of. Here simply we will go the armature and we will say, so this is the shaft made up of steel, and these are the brushes connected, so carbon, and winding coil, copper, enameled copper. So this is the stock slats and everything. So this is armature stock I am dealing. So these are commutator bars, so copper, shaft already discussed steel, bearings with the carbon steel, and stator field winding. So field winding is copper, enameled copper. Okay, so clearly we can understand what is the made up of, what is the purpose. So this is some of the construction for your understanding purpose I made. So go through it. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.